All right, everyone, welcome to my talk on static code analysis with Python. I'm Andrew Wolfe. I didn't introduce myself. You don't know who I am. Quick plug, I work at OnShift with a bunch of other fine people. We're hiring, so if you're interested in working with some of the best people in Cleveland, Ohio, we have developer positions, scrum master positions, product analyst slash product owner positions. Feel free to apply. Our website's onshift.com. So today's goals. I'm going to provide a basic introduction to static analysis as a field, demonstrate some tools in Python that provide various benefits when it comes to static analysis, and demonstrate the value that static analysis can provide to developers and stakeholders at your business. What is static analysis, right? It's a good question. It's a process of analyzing code without executing it, right? So when you look at code, it's just text in a file, obviously encoded, and you can take a look at the code without executing it and glean information from it. You can, just like a compiler or a interpreter, you can figure out things about the code, about a function, the inputs of the function, even determine some of the execution paths in the function in your code to determine bugs prior to running it, or other things such as never mind, wrong slide. Why use static analysis? Like I said, it provides insight into your code without executing it, meaning it always terminates, right? If you use dynamic analysis, which is another type of analysis, which was running the code and providing input and seeing what it does, it may not terminate. If you have an infinite loop or for whatever reason your code doesn't terminate, dynamic analysis will therefore not terminate. Static analysis doesn't have the same pitfall. It executes quickly relative to dynamic analysis as well. When you execute the code, you have to provide a lot of input to see the various conditions your code executes under. You can automate maintaining code quality within a code base. You can find some bugs fairly easily. You won't find all of them, but it's a very low-cost way of finding bugs. And you can find some security vulnerabilities early as well without having to actually ship the security vulnerability to production. You're already using it. So if you're using PyCharm or you're using any kind of IDE, it's using static code analysis to provide you rich feedback when you're doing your development. And it's really easy, as I'll show you, to incorporate into your project via CI/CD or via the command line. So what kinds of static analysis exist in general, right? Code styling analysis, security linting, error detection, UML diagram creation, duplicate code detection, complexity analysis, secret detection, which I'm going to define as you may have a password somewhere in your code that is connecting to some sort of web service or file system, and you want to make sure that that isn't in your code, so when you push it to GitHub, you don't have something embarrassing like a password leak. Comment styling analysis, unused code detection, and framework best practices analysis. As I'll show you, it's very easy to incorporate all of these into your project in Python. So it sounds really awesome, right? The static analysis is really cool stuff, but it's not a panacea for quality, right? It's not going to solve all your problems. It's not going to make you a amazing code base. You're going to have other things to do that. But, there's false positives and false negatives, right? It may tell you you have a bug when you don't. It may think you have a security flaw when you don't. And those are going to show up when you run the analysis tools. False sense of security, right? You think you're catching all the bugs. You think you're catching all the security defects with your static analysis, and you're not. It's very easy to fall into, well, static analysis told me I had no problems, so I have no problems. Runtime bugs and vulnerabilities are not included, right? I mentioned dynamic analysis. Those kind of things static analysis can't catch, right? So if you have some sort of cross-site scripting vulnerability, which is letting JavaScript get executed in some sort of context, that won't be caught if it's not very simple appending input from JavaScript. So some tools we're going to demo today. Prospector, which is actually a giant conglomerate tool of static analysis tools. Bandit, which is a security static analysis tool, and PEP8 with the editor integration, which if you use in PyCharm, I'll demonstrate that quickly, but if anyone uses PyCharm in here, I know some of you do, you don't have to really think about it, but it's actually using PEP8 behind the scenes, which is a library. So Prospector, it's the one ring static analysis tools in Python. It incorporates Pylint, PEP8, PEP256, PyFlakes, Macabre, Dodgy, Pyroma, Vulture, and actually a few others I didn't include because they're kind of being sunset from the project. All of this, and it executes relatively quickly on a fairly large code base. I think we have a code base of around 400,000 lines last time I ran it, and it ran within 15 seconds. So I will demonstrate how easy it is to actually get Prospector to run. Can everyone see? It's got to be big, and it can't be this color.
If you can invert the polarity of your colors, that'd be great.
Yeah.
Text on white background.
I'm seeing if I can. Let me see if. Yeah, I think it's the colors too, though. So, so I can make it bigger. Can everyone?
That helps. Keep going.
Okay. So this is a project I've worked on. In the
Flip the colors. Like your brown is
yeah.
almost invisible.
I don't know actually.
You're on item, press Command I. Colors, bottom, color presets.
Light background. Better? Teamwork. All right, so this is a project I've worked on in the past. It's an image overlay project. It's effectively just a wrapper for Image Magic, if you've used Image Magic before, and Pill, well, Pillow. I think it's old enough to still use Pillow. And all it does is overlay an image on another one, which isn't too fancy. So this actually has nothing too complicated in it, but what I'm going to do is I'm going to make a virtual env. I'm going to call this a demo. It's going to do that real fast. And then I'm going to pip install. Actually, I'm going to show you that I have nothing installed here, right? Pip freeze. I have wheel. That's it. So if I do a pip install prospector, all right, we're going to install Prospector. It's going to install all of our tools for us. Cool. And then all I have to do is literally type Prospector, right? I've incorporated it into my project. That simple. Right, and so Prospector has a very rich documentation. If I pull up Chrome, come over to the website, right? Lots of configuration options. It has adapters for Celery, Django, and Flask. You can set the various strictness levels. Profiles are set in a YAML file. You can turn on and off tools, turn off strictness, set an error rate so that you can really fine-tune it to what you need. For example, our project that we run this against has around probably 1,000 or so violations, maybe more. So we set it such that we don't get any worse, knowing that we're not going to fix 1,000 violations in a day. I advise doing the same because most projects are not going to be perfect. Some things that you will most likely have to tune are the line length. It requires 80. Most people don't use 80 character lines. The tabs, I think, are set for spaces, so if you're one of those people that use tabs, I'm sorry, but you will have to configure it to use tabs. So the next tool, if I can load my presentation, is Bandit. Bandit is a tool created for the OpenStack project to do security testing on that. And they open sourced it. it's a security defect thing that's similar to Coverity if you've worked in Java or .NET. And it can detect things like hard-coded passwords, invalid pickle serialization and deserialization, shell injection, SQL injection, and is a great plugin system that's very easy to extend. So it's really anything you want to write. So I'm going to demo that as well and show you how easy that is to get installed. So if I do a pip install bandit, and then I write bandit-r app, you will see that I have, in this project, tons of shell injection, not on purpose. Just I have concatenated random input from the command line to make my job very easy. But if someone wanted to take this, and it is a web service, I'm not going to tell you where it's hosted, you could do some pretty evil things to this program. And you can see that this actually has a confidence interval, which the other tools don't. And I'm going to talk about that for a second. It may say severity high, right? It might say SQL injection's a high severity bug, but the confidence could be really low, meaning that we're not really sure it's SQL injection. It just kind of looks like SQL injection because you're concatenating these strings and passing it in. But you may have escaped it up, and it doesn't know that, right? Static analysis is not really doing any runtime. So it will do that. And so you can actually, on this project, Bandit, I will show you the GitHub page. As you see, it's really easy to set up, and it has a lot of good documentation as well, how to write a plugin. There's great examples on how to do that. I think they have 40 some odd plugins built in for various types of injections. So it's actually pretty full featured compared to Coverity, which you have to pay, I think, like 10 grand a year for in Java land. It's almost as good as Coverity is. You can tell it to skip various things. So if you don't care about SQL injection, you can have it skip. You can tell it to run certain tests. You can tell it to do various confidence intervals. So don't report anything that's low confidence to keep your build green and all of that. So I wanted to show you the PEP 8. So I'm going to go back over to my terminal, and hopefully this works. I did not try this with this. That is completely unreadable. That's my Vim styling. So I don't know if I'm going to be able to demo.
Go back to that one.
Oh, you know what? I can actually edit my Vim RC and just turn off my colors. Okay, let's see if that works. Is that readable? Hopefully you can read the files when I load one.
Are you using Tmux?
No.
Well, we're missing, I don't know, 5.
So you can, for the demonstration purpose, you don't have to read the code, I guess.
Don't look behind the camera.
The arrows on the side are Flake 8. So what I've done is I've installed Flake 8, and it will go through and provide linting inside my Vim editor, because I use Vim, similar to how you would get in PyCharm. And so similar in PyCharm, I can go over here and demonstrate that real fast on another code base. And then as you can see, this abstract field import isn't used, so it tells me it's not used, which is also not noticeable. I should have picked better colors. All right. So can you write static analysis tools? Absolutely. Actually, Python makes it easier than many other languages by giving you a module AST, which is the abstract syntax tree, which I won't get into, but it's essentially the syntax tree of your file. Of this is a function, this is a variable, this is a, and you can use this to analyze, right, and figure out and write your own tools if you find one that doesn't meet your requirements. And a lot of the open source things give great examples of how to use AST. Bandit in particular makes heavy use of it. So if you go to the Bandit repo, you can pull down the code and really figure out how to parse the AST and write your own tooling. There's some tools we didn't cover. PyChecker, it's very similar to Pylint. It actually has a few more features that Pylint doesn't have, but Pylint seems to be the de facto standard. So we decided to use that, and it's included in the Prospector library. MyPy, I'm going to talk a little bit more about why the MyPy project is actually really cool in a second. So I'm going to skip over that. PySonar, it's a static type checking prior to Python 3.5 and PEP 484, which is the types in Python. This was a project made by a Google code student while they worked at Google to basically provide typing in, or type suggestions in Python. And there's a bunch of other tools that we didn't cover. You know, the ecosystem's huge. So MyPy, why is MyPy important? So if you look at it, it's effectively similar to how TypeScript provides types and compilation to JavaScript. This project does a similar thing to Python, because it doesn't compile your code, it just uses static analysis to use the type hinting in PEP 484 that was introduced in Python 3.5. And a lot of people get really freaked out that you're adding types to Python, like get your Java out of my Python, but it's really important because the tooling that can be enabled by typing is similar to JavaScript, right? Before you couldn't do like function lookup in JavaScript because it didn't have modules. Well, TypeScript gave you modules, so now you can control F5 into a function, right? Making JavaScript development much easier. And types also, type hinting gives you a lot of other tooling options as well. So in Java, there's a library called Randoop, which can basically generate all your unit tests for you. And it can do that because it knows the input types of your functions. So it knows that if it provides a list of some type and gets the result, it can rate and assert those unit tests for you. We can't do that in Python because we can pass it anything and then watch it blow up and guess, right? But it may never terminate. So those libraries are enabled by using PEP 484. So I advise everyone looking into MyPy. I think it's really cool stuff, and definitely something that I think when people start adopting Python 3.5 that will get lots of traction, and it will definitely make Python more popular. So next steps. Static analysis, all the things. Incorporate into your projects, into your CI/CD builds, right? This is a great way of enforcing quality in your projects and making sure that you catch some bugs. Create your own static analysis libraries. So like I said, Python makes it really easy to go around and play around with ASTs and figure out, find out if you can do some meta programming with AST. You can make some cool tooling around your projects that way. And contribute to other static analysis libraries. I have a plugin I've been working on for the Bandit project for a little while now. I'm going to actually do a pull request probably next weekend to get that in there. And it's really rewarding, I guess, to do that kind of stuff. It's actually kind of fun to play around with grammars and figure out how security vulnerabilities work from a static analysis standpoint. So I kind of blew through the entire presentation in around 20 minutes, so you get most of your 50 minutes back, which is fantastic. But does anyone have any questions?
Yeah, I was wondering if you could use the static code analysis for doing any
Go ahead.
okay, for checking coding styles.
Absolutely. The question was, can we use static analysis to check coding styles? Absolutely. So Prospector has pep8.py included in the project, and that does all the pep8. So actually, I'll show you. I'll X out of this. I'll actually show you the output of Prospector. So if I go up, my config.py pep8 violates E101, which if I'm to understand that, it's my indentation contains spaces and tabs, which makes me a bad person. And so pep8 is violated here too. Line break before binary operator. I don't even know what that. I guess I do know what that means. But So you can use it for any kind of code styling, not just PEP 8. If you have your own, you can definitely customize it to do whatever you want it to do.
Next question?
You didn't really cover any security analysis. Can you speak to that? I guess what static analysis around security?
Yeah, so I'll show you Bandit once again. I have to do bandit-r app. So effectively what it does, I'll give a quick overview of what that means and how it figures out that this could potentially be a shell injection attack. So a shell injection attack, if you're not familiar with that, means that I could pass you a shell command and you may execute that without you knowing that your code's executing that. So let's say you're running your application as root. I might be able to just shut your server down, right? Exit or init6 your server, right? Now restart it. I could maybe pass me your users or your sudo file and figure out how to do that. I could do lots of malicious things if I had root access. In fact, I can own your entire application. And if you have shared SSH keys, which a lot of people do, very common attack is I find one vulnerable server that has all your SSH keys on it. I can then take your SSH keys and then proceed to SSH into every one of your boxes and get whatever corporate secrets I want. In that case, what static analysis does to determine this is I have os.system call. I append a string, in this case temp string, very, very aptly named. And maybe if I were to terminate this, so with a and would be a terminating thing. So I do a convert and my command and I pass that string in there. Maybe it's dumping your SSH keys. I might be able to take that vulnerability and get what I want. So it looks through this code, sees that I'm appending strings together, and thinks, well, maybe that you're appending a string, and that string isn't sanitized upstream, and so therefore it's possibly a vulnerability. It does the same thing with SQL injection. It can tell that this is SQL, right? Doing just, hey, select statement, select star from, plus, right? You're appending that string together, no sanitation, no kind of library stopping you from, something like a prepared statement. So therefore, it's probably SQL injection. And because I can analyze and look at the characters in the code, I can figure out pretty confidently that you have a SQL injection vulnerability. Same thing can be done with cross-site scripting. Passwords are very easy to determine. Usernames are very easy to determine. There are a few others. Pickling, serialization and deserialization is pretty easy to detect if you're deserializing or serializing something that could potentially be malicious. There's a thing called billions laugh attacks, which is effectively making an XML deserialization attack that causes the XML to balloon to gigabytes and potentially crashing your server. Those kind of attacks are easy to determine because you're not sanitizing input, you're not doing something that you should to avoid them. Answer your question, Justin?
Yeah, sorry to cover this. I was more just interested like SQL injection and things of that nature, so that's good.
On XKCD.
Anyone have any other questions?
Not so much of a question, just as a quick random note. Coverity does now support Python in Coverity 7 and is free for open source use.
That's fantastic.
So if you have actually ever run into Coverity and want to try do that for your project, you can.
You'd have to be a real masochist to like Coverity.
Maybe, but it's there. They do offer it as a hosted service. That's also a nice upside.
That is actually very nice. So.
Next question?
Anyone? Bueller? All right, guys. I want to thank you for coming to my talk. I blew through it pretty quickly. But if you guys have any questions, I'll be here for the next 30 minutes, probably.
What's your contact info?
Yes, you can reach me at awolfe@onshift.com. Andrew W. Wolfe. I'll actually type it up here. It'll make my job a little easier. And then the beginning of that is same on Twitter, GitHub, and pretty much any other service that you think I'd be on. I'm not on Instagram, though. 3 W's in a row. Oh, you have another one? Cool.
Another thing that I thought about just now, on your test cases that you said you can't easily generate automatically, are you aware of property-based testing approaches?
Yes,
and
hypothesis.
Yes.
So hypothesis is cool.
Not quite the same thing, but it is useful for generating that kind of input.
Yeah, so it's useful, but without typing, it can only go so far, right? So you kind of have to suggest the type to hypothesis anyway. So you're attaching a type to your fields. By saying, hey, this field's an int, it can figure it out. But if you already had those types in your code, it'd be hypothesis be able to run automatically. So it would once again provide tooling benefit even to hypothesis. But hypothesis is a cool tool, and if you're not familiar with what that is, it effectively is a property-based testing tool that allows you to provide a type to something, maybe an input, and then it can generate values for that input. So maybe you have a function that accepts an integer and a string. As long as you tell hypothesis that this is an integer and a string, it'll pass in random strings and integers to your function and assert different functionality for you. So it does do a lot of testing for you, and it's pretty valuable. I think it also uses, you can use doc strings to tell it your type as well, like 90% on that. Cool. Thank you, guys.